Proposed modifications to the Big Bang Theory, Part 1. In search of solution to the current crisis in cosmology. The James Webb Space Telescope finally launched in December 2021, and in January 2022 it arrived at its destination, the second Lagrange point.
Then, although the JWST has only been conducting science operations for a few months, it has already made some iconic discoveries, including the detection of what could be some of the earliest galaxies ever seen, that existed just 300 to 400 million years after the Big Bang. And even worse, the discoveries of stars that are older than the universe, or galaxies that are considered older than the Big Bang. The strange discoveries highlight the deepening mystery of how large galaxies first developed in our universe. These findings caused a stir in the world of astronomy because they appeared to contradict the Big Bang theory. Some scientists argue that the findings cast doubt on theories of galaxy evolution or even their understanding of the universe. Because, according to our standard model of cosmology, these types of galaxies would require substantial amounts of time to form, grow, and evolve.
But in fact, the discoveries of these earliest galaxies found between 300 to 400 million years after the Big Bang, was simply the final blow to our modern cosmology and the standard model on which it was based. Some observation findings, since the Big Bang theory introduced a century ago as listed here, provide ambiguous support to the theory. Earlier findings support the theory, but the latest findings contradict it. Some facts discovered since the Big Bang theory introduced more than a century ago. 1. Some galaxies are moving away from us. The further away the galaxies are from us, the faster they are moving away from us. 2. Some galaxies seem to disappear from view, and become invisible. 3. Some galaxies such as Andromeda are approaching us or blue shifted. 4. There are large, fully developed, and brighter galaxies, found between 300 to 400 million years after the Big Bang and even some found before the Big Bang. 5. The universe appears to be flat. 6. Cosmic objects are not distributed evenly, there are cosmic voids in the universe. 7. Some cosmic objects, such as massive galaxies, planet, satellite, were formed by collisions among them. Observation findings on the list, starting number 3, have raised doubts about our standard model which is based on the Big Bang theory. The theory of the beginning of the universe that has established more than 100 years ago. Observation finding number 1, namely, some galaxies are moving away from us. The further away the galaxies are from us, the faster they are moving away from us, and observation finding number 2, namely, some galaxies seem to disappear and become invisible, basically support the Big Bang theory, whereas the observation findings number 3, and so on, seem to contradict the theory. With all of these observation findings and discoveries, is modern cosmology and the foundation of our standard model, the Big Bang, in trouble? Is our understanding about the universe completely wrong, or the Big Bang never happened? Results are mixed. Some scientists say that the JWST's findings never disprove the Big Bang theory, but many others say the other way. Since these recent discoveries, cosmology appears to have been plunged into a crisis that could reveal new physics or even break the standard model. What can we do to solve it? Should we abandon the theory? Is it the time to throw out the Big Bang theory? Maybe it is not necessary yet. We don't need to be in such a haste. Let's make an effort to try to modify, revise, or just upgrade the theory. But before that, let us revisit the Big Bang theory. According to the Big Bang theory, the universe was born as an infinitely hot, very dense single point in space. It underwent an incredible growth spurt. During the burst of expansion, which is known as cosmic inflation, the universe grew exponentially. Since they were formed, the Milky Way and all other galaxies in the universe started moving and had been traveling in the straight-line path from the direction of the point of explosion to their current position, like spoke on the wheel. None of them are on the parallel path. Their paths also never intersect each other. We, on the Milky Way, can see other galaxies traveling on their own path so long as they are in the coverage of our observable universe, or we can just say, in our miniverse. The galaxies seem to recede as they are moving away from the point of explosion, or from the singularity. The farther away the galaxies are, the faster they are moving away from us and eventually disappeared from our miniverse. So, in this case we can say that the Big Bang Theory can explain observation finding number 1, namely, some galaxies are moving away from us, the further away the galaxies are from us, the faster they are moving away from us, and observation finding number 2, namely, some galaxies seem to disappear from view and become invisible. However, the Big Bang Theory could not explain all the others' observation findings: the galaxies with blue shifted, the appearance of large fully developed and estimated old galaxies, the existence of cosmic voids, the flatness of the universe, and the collisions that form giant galaxies, planets, and satellites. What should we do to modify the Big Bang Theory? Firstly, what we could do is to try to interpret, differently, this observation finding: some galaxies are moving away from us, the further away the galaxies are from us, the faster they are moving away from us. Rather than interpret it as the expansion of the universe, we could interpret it as galaxies that are at a distance from us are traveling on paths with different shapes. Not straight lines, but curved in such a way that there is a visible difference in the speed of moving away between those which are closer and those which are further away from us. The reasons for this thinking are as follows: 1. That the universe seems to be expanding at different speeds in different directions, depending on which direction we look. 2. There are some scientists who doubt that the universe is indeed expanding, and 3. There are some other scientists who suspect that the universe has stopped expanding. In the original Big Bang Theory, the moving path of the objects is straight line as the objects moving away in every direction, from the point of explosion, or the singularity. As depicted in this illustration, if two objects are moving in different paths, they will eventually be separated from each other. The further away they had traveled, the more distant they are separated. This kind of object separation would also happen due to different shape of paths they are traveling, not straight lines but curved, like the spiral arms of a galaxy. Assuming that all galaxies move at the same speed, we can see that the effect of the galaxies moving away from each other can be explained by this curved path model. So, by this model, we can explain how we, in the Milky Way, can see other objects or galaxies on a different path, or different arm, are moving away from us. The further away the galaxies are from us, the faster they are moving away from us, and finally disappeared. Now, let us focus on the galaxy whose path leads directly to our Milky Way galaxy. In contrast to the original theory, we can see that this curved path model allows, at certain times, for galaxies to approach each other. The following illustration, assuming that all galaxies move at the same speed, may explain why some galaxies, such as Andromeda, are blue shifted. Therefore, the observation finding number 3, namely, some galaxies, such as Andromeda, are approaching us or blue shifted, can also be explained by this model. Secondly, from the original theory, we can conclude that if an object, in the same path as our Milky Way, moves in front of us, it will be considered older than the Milky Way. And if an object moves behind us, it will be considered younger than the Milky Way, because they all had been moving away from the point of explosion, or the singularity. And also because the object in front of us has traveled a longer path while the object behind us has only traveled a shorter path. Likewise with the curved path model, if an object, on the same path of our Milky Way, moves in front of us, it will be considered older than the Milky Way, and if an object moves behind us, it will be considered younger. For the same reason that they all move from the same point, namely, the point of explosion or singularity. Conclusion: the galaxy moving in front of us is older than the Milky Way, and the galaxy moving behind us is considered younger. Given this conclusion, how can we explain the observation finding number 4, namely, there are large, fully developed, and brighter galaxies, found between 300 to 400 million years after the Big Bang, and even some found before the Big Bang? How do we explain the finding of a galaxy that has the properties of a galaxy older than the Milky Way? To make sense, all of the cosmic objects should travel in the reverse direction, not moving away from the singularity, but instead, approaching the singularity. In such a way that the movement of the galaxy looks like in the following illustration. This galaxy will be considered older than the Milky Way because before it reversed its moving direction, the galaxy had traveled further from the explosion point than the Milky Way. The next question is, how to explain the phenomenon of this reversal moving direction? My hypothetical answer is as follows. Let's start with the big explosion. The explosion disperses remnants in every direction. Then, these remnants started traveling and moving away from the center of explosion in an unimaginable speed. At the same time, the big explosion also created emptiness in its center, which, in turn, created a spinning vacuum energy, or we can call this as huge enormous giant black hole. This energy began to pull the traveling objects toward the center of explosion, causing their traveling speed to slow down, and finally stopped. Afterward, the objects began to be dragged to the center of explosion and started traveling in the reverse direction. In this illustrated animation, first, the big explosion drives the remnants away in every direction from the singularity. Then, a spinning vacuum energy created from the emptiness. The vacuum energy began to pull objects from every direction toward the center of explosion. Traveling speed of the objects slowed down and finally stopped. And then, all of the cosmic objects began to travel in the reverse direction. Because the shape of the vacuum energy is like a spinning giant ball, it pulled all the cosmic objects in such a way that finally look like they are being dragged on the sheet of fabric just like stars on a galaxy. So, the galaxies in the local cluster arranged in such a way that the cluster will look flat. And, the movement of galaxies in one cluster will look like in the following illustration. By this model, we can explain observation finding number 4, namely, from our Milky Way, we can see large, fully developed, and older galaxies. Because they actually had traveled longer way from the singularity than our Milky Way, before all of these objects moving in the reverse direction. By this model, we can also explain observation finding number 5, namely, the universe appears to be flat. So far, we have explained two modifications to the original Big Bang theory, namely, first, the paths of the movement of the cosmic objects are no longer straight lines, but replaced by curved paths. Second, cosmic objects are no longer assumed to continue moving away from the singularity, which is perceived as the continuing expansion of the universe, but rather, these objects are already moving in the opposite direction, namely towards the singularity. With these two modifications, we can explain observation findings number 1 to number 5. The explanation for the remaining observation findings will be presented in the next video, namely, proposed modifications to the Big Bang Theory, Part 2. Thank you for watching, see you again in the next video.